All right, let's kick her off.
All right.
Hello and welcome. You can hear, right? All right, fantastic.
Wow. So fun with giant spotlights right in my face. I can't actually see anybody, but I assume you're out there.
I'm Brian Lewis, a solutions architect with AWS, and with me I have Kirk.
I'm Kirk Davis, also a solutions architect with AWS. I'm on the .NET. I'm a .NET specialist SA, so I deal a lot with ASP.NET and .NET apps on AWS.
And I work with Microsoft workloads on top of AWS, all kinds of them, including .NET.
So we have some related sessions. I don't actually have the dates and times on these, but these seemed related to the topic. So if you're here for containerizing legacy ASP.NET apps, you might be interested in one of these. So feel free to check out them on the schedule. I don't have it. Okay.
What we're going to cover today is we're going to go over the basics of Docker first. And then we're going to go over why we'd want to Dockerize a legacy .NET app. The next piece we'll go into is containerizing that .NET app. We're going to go through a sample app and containerize it. And then lastly, we'll look at deploying to ECS and running it on top of a ECS environment.
All right. So before we get started, though, I wanted to talk about get a show of hands of people who are doing like .NET development or .NET DevOps, something in that. Okay, oh wow, a bunch of hands. So probably most of you know this already. The title on this slide is actually a quote from Scott Hunter at Microsoft. He's the director of program management for .NET. So .NET is the future, .NET Core is the future of .NET. .NET Framework 4.8, which just dropped, I think, this spring, is the last major version of .NET Framework. They're going to continue to release security patches and minor bug fixes and things like that, but there's never going to be a .NET Framework 5. There might be a .NET Framework 4.9. I'm hearing probably not, but that's possible. But all future, the key takeaway is that like third bullet down, all future investment in .NET at Microsoft is on .NET Core. And they're going to be releasing it every other year. And then after .NET Core 3 and 3.1 ships this fall, the next release isn't going to be called .NET Core 4 because they wanted to avoid confusion with .NET Framework 4 and .NET Core 4. So it's just .NET 5. It's no longer Framework or Core. I think they said you can continue calling it Core because for a while it'll probably be less confusing, but it's just going to be .NET 5, .NET 6. If you see the LTS, long-term support, those are the versions of .NET Core, soon to be .NET, that will get the long-term, security patches and stuff like that for 2 years, as opposed to the shorter, the alternate versions that come out on even years. So at AWS, we support .NET and Framework across a variety of compute. So .NET Framework we support on EC2 and in Windows containers. .NET Core we support in Lambda, long-term support releases in Lambda. You can run in Fargate. You can actually use your own layers in Lambda to run whatever version of .NET Core you want in a Lambda function. So basically anything new that you're building should be built on .NET Core. If you're starting a new project, don't start it with .NET Framework, start it with .NET Core.
Can you go back to that for a second? Something that hit my memory was the original name of .NET Core 1.0 was going to be, before it shipped, was going to be .NET Core 5.0. And then they changed it before they shipped it to 1. So it was always going to be, the planned next generation. It's just taken a couple versions now to get to 5. So we should have 3 ship this summer. And the difference between Core versus the framework, the framework only runs on Windows servers, where the Core will run cross-platform. It's open source, it's
modular, it's lightweight.
Yep.
So .NET Core is distributed through NuGet. You can add, it's not monolithic, you can run side-by-side versions. So we're not saying that your .NET Framework apps are bad or that you should throw them away, because they will continue to run. You can continue to extend them and build them. Just for new things, use .NET Core. There's a common perception I see online where people think that AWS doesn't support .NET, or we don't really do anything for .NET. And I just went and grabbed I think 8 different releases that were focused on .NET that we did this year, from releasing PowerShell standard support. Lambda layers was kind of a big one because it allows you to run .NET Core 3 if you want in preview. Preview 3, I think, is the latest. You can run that in a Lambda function with the bring your own runtime, that Lambda, the Amazon.lambda.runtime support for custom Lambda runtimes. Basically, we have a lot of iterations of new services or features that are related to .NET. And I'm one of, I don't know, a half a dozen .NET specialist solution architects at AWS, so we're advocating on behalf of .NET developers as well. Why containers?
Why would you do containers? Well, so let's talk about what containers are first. Containers are something that gives us a very similar thing to a virtual machine. So that gives us portability, right? I can run on any piece of hardware and not have to worry about the drivers underneath. It gives me the ability to run multiple versions without them stepping on each other on the same host. So why don't I just do virtual machines? Virtual machines are much heavier. So if I can run 10 virtual machines on a server, I may be able to run 20 containers or 50 containers. Containers are generally a lot lighter weight. Startup times for a container, when I reboot a Windows container, like a nano server Windows container, a reboot is sub 1 second. So that's kind of nice, because even in my VM, it doesn't take 1 second to reboot that guy.
Your laptop doesn't boot that fast?
My laptop doesn't boot that fast, and my server, when it counts through the memory, boots even slower. So containers are really nice from that aspect. The thing that's different on containers is you're not emulating all of that hardware. You're basically riding on top of the kernel. So that means every container or every different thing running has to be running on the same version. You can't run Linux next to Windows, next to Solaris. You can't do that. You have to run not only, and in this case, Windows Server, you have to run the Windows Server version. So you can't run 2016 and 2019 on the same host. It's got to be whatever that host kernel is.
Do we have, show of hands, have any of you used containers? Is everyone familiar with the concept of containers? All right, so it seems like most of you are at least
So
familiar with
Linux
that.
containers, people have been doing for quite a long time. I would imagine those hands, I'll just ask another one. Who's doing Windows containers today?
Oh, wow.
Oh, fair amount.
More than I would have guessed. So
Excellent.
I guess we can talk to you about the difference between the two different ways a Windows container can run on Windows. Brian was saying that the versions have to match. If the versions match, then you can run the container directly and it will share the same host kernel. So if you're running on Windows Server 2019, which is a much better thing to run containers on than 2016, then if you're running Windows Server 2019 containers, they'll just use the underlying kernel, and it's just the app layer basically that's going to be running on top. Libraries, .NET Framework versions like that.
So go to the next one. So if we look at this next thing, how do I then take my laptop and build stuff for the server on there? Well, one of the ways to fix that would be run a hypervisor and then run the server kernel on your development machine. So I'm still running Windows 10 on my development machine. I don't have to load server on my laptop. But when I go and play within the Visual Studio or just in Docker itself, I'm going to run on top of a hypervisor and run that kernel there, and then I can load my Docker container on top of that. Right? So that means I can basically code to server 2016, 2019, whatever, it doesn't matter, because I can run that kernel.
Yeah, and it's because I have a Windows 10 laptop, but I'm deploying to Windows Server 2019 or Windows Server 2016, but because on my laptop it's running in Hyper-V mode. Anybody who's done Windows containers on your laptop, have to enable Hyper-V and maybe change a BIOS setting and then reboot. That's the reason why. So why containers for legacy .NET apps? So there's three main reasons that we see customers taking their legacy ASP.NET apps. They're traditionally ASP.NET. There are customers running other .NET apps. If you're running a thick client, though, it doesn't make any sense to containerize that because it's got a UI that users have to interact with. Could be a batch job that's a .NET console app or something, but most commonly it's ASP.NET. So the three big reasons I see customers doing this is they're moving to the cloud anyway, and they've got to take these legacy apps along with them and support it, or they're looking to save money and get more flexibility by moving to the cloud. So the question is, how do you do that with an ASP.NET app? So by ASP.NET, I mean .NET Framework, not .NET Core. If it's .NET Core, there's other things you can do. Run it in a Linux container or move it to Fargate, whatever. If it's a ASP.NET Framework, like an MVC, or especially like a web forms app, there's no way to migrate web forms to .NET Core anyway. It's not a supported project type. So and there's a lot of them out there. If you see the URL ends in .aspx, that's definitely web forms. So rewinding, the three big reasons are like operating system utilization. If you're running, and I've seen customers running 15, 20 different ASP.NET apps in their data center, and because each one's in a slightly different version of the .NET framework, they're all on different machines, all of which have to be maintained and administered. Every one of those machines is a Windows Server license that they're paying for. If you move that to container, you containerize those 20 apps and then move it to the cloud, you can run it all on one machine. You've got one Windows license, and anybody who pays the Microsoft tax is aware how much Windows Server licenses cost. Second big reason is deployment and runtime consistency. That means if I'm a developer, and I have done this, I was a developer for 20 years, if I'm building on my own machine and I've got IIS and SQL Server Express, I've got my own configuration and I run it locally and everything works great, and then we deploy it out to Windows Server 2016 and the operations guys deploy my app on that server and it doesn't work. And it's because subtle changes in configuration, some registry settings not the same, whatever. And so you end up in this cycle of, okay, I have to remote desktop onto that prod box and then try to figure out why it's not working. With containers, once I have this container running locally on my machine and it is working and everything works, I can take that exact image that I use to spawn the container locally, and I can take that image and use it to deploy the exact same container to a server in the cloud, in my data center, in my closet, wherever, and it will run exactly the same.
In your closet?
It's encapsulated. Well, nice. I have a server in my closet.
All right.
My wife's really happy about that. And the last thing is scaling.
Do you have a chiller hooked to that closet?
Do I have a what?
A chiller? Cooling your closet?
Maybe. Last thing would be scaling, just the ability to rapidly scale up. Brian mentioned like Nano Server can boot in under a second. Even the bigger Windows Server Core, which can run ASP.NET Framework and IIS-based apps, that's a couple of seconds to boot. It's much faster than booting a hardware instance or even a virtual machine. And Windows virtual machines, even in AWS, we've done a lot of work to improve it. It's still a couple of minutes to bring up one of those things. Whereas the container will boot on the order of 10 seconds or 7 seconds or something. So you can rapidly scale out your applications. So we're going to walk through each of these.
One thing to add to what you said about the legacy, the reason you want to run these legacy apps is a lot of them can't port right now, excuse me, to .NET Core. But Microsoft keeps adding APIs and functionality, and so when 3 comes out, when 5 comes out, because 4 is not coming out, they should be adding functionality that will make that port a lot easier, and so it might fix that for you.
Web forms, probably not, but there is an open source effort for WCF, a limited support for WCF, which is not baked into .NET Core, but we can talk about that at the end. We have a modernization section. So for operating system utilization, this is kind of if you're in your data center or even in AWS running on EC2 instances, I might have these 3 apps. I've got it, I want multiple copies running. Maybe at peak load, I've got 4 copies of each. So I'm running 12 total applications on these 4 boxes. And each of these boxes is running, say, Windows Server 2019. So that's 4 Windows Server licenses. Whereas if I'm running Windows Server containers, then I can basically, you see W3P, that's the World Wide Web Publishing Service, which is what you're using to publish ASP.NET web apps or the web server. So I can run my own copy of that inside of these containers. It's still running in the same Windows Server kernel underneath, but now I can have different configurations for each of these as well. They can each be running on the default website, because lots and lots of legacy apps I've seen are configured to only run on the default website, and nobody really has the source code and wants to go figure out how to make it run 8 websites on a server.
And those can all be standard.
And this can all be standardized across all of them.
Thunder, sorry.
So I think I kind of skipped ahead, but you could basically, if I'm running with Docker containers, there's a Docker engine that's going to be running on each one of those servers. I might have the same 12 apps, but here I'm only running 4 Windows Server licenses instead of 12. Not sure what I said a minute ago, but it was 12 server licenses, now it's 4. The reality is you could even do better than this, because those containers, if we go back a slide to here, you can see the guest OS, it's actually not drawn to scale, because the reality is a Windows Server OS is 12, 15 gigabytes, and then your app is probably 500 megs maybe, if that, maybe 200 megs. So it's a really thin slice. The OS is the big fat thing hogging up a lot of space in your server and memory. So when you go to Docker, if you've containerized them, instead of running 3, the reality is you can probably run 4 or 5 or 6 on that same hardware. Then you could even decrease the server count to 3 and end up paying for 3 Windows Server licenses instead of 12. So you can get a lot of savings, especially companies that are running lots and lots of these. Going from 12 to 3 or 4, okay, I've just knocked off 8 Windows Server licenses. It might not sound hugely, but if you're running 1,200 and you've reduced it to 350, that's a lot of money. So deployment and runtime consistency, I talked a little bit about this. Developers can build these containers, test, build, code locally, take the container, push it up to your test environment, run all your tests. The container will run the same on your test environment as it did on dev and exactly as it is going to do on prod. You're not going to have this differences between, well, my test environment's running a slightly different KB knowledge base patch version than my production environment is, or it's 2 weeks, prod is 2 weeks behind on patches, and therefore they're no longer perfectly high fidelity environments. So with containers, it's the same thing everywhere. To containerize an app is really pretty simple, conceptually. It is just really adding a Docker file that gives Docker instructions on the files and commands you want Docker to run. It's generally just one text file. You can edit it in Notepad. I usually edit mine in Visual Studio or Visual Studio Code, and I'll show you one later during the demo. So that this Docker file generates a layer, a container image. So this is an image. An image is actually made up of multiple layers, but in this case, we'll call it an image. Every image gets a unique ID, it's sort of like a GUID. If I step through this, the entire image is made up of, in this case, this hypothetical one, it's 4 layers. The OS layer is the biggest, and then finally the app layer is on top. This is immutable. Once you create an image, you can't go in and start editing the image and making changes. If you want to make a change, you just create a new image. And this leads to a lot of benefits later. Instead of deploying a production app and then as things change over time, you're patching it, and then somebody went in and changed a registry setting because they read a blog article to solve something, and then 6 weeks after that, somebody installed Notepad++ on the server because they were trying to edit something, and eventually you end up with a server that's in a state that's not really known because it's been hacked on for the last 2 years by your admins. With a container, you go back to the source and you recreate it each time. So it's immutable. And then finally, when your Docker container gets placed somewhere, these bottom layers, like I said, they're all immutable. There is a read-write layer, so if your application needs to write things locally, write to the local disk drive, it thinks it's writing to a server disk drive. It's actually writing to a special an abstracted file system that only the container, it's only specific to that container.
And so when you shut down that container, those files are lost, right? Wow, I'm really losing my voice.
Yeah, he's getting sick, so don't let him breathe on you. So for scaling, one of the reasons it's so fast to scale is the very first time a container gets placed on the host, this is the server, all the layers that make it up have to be pulled down, especially that 7 gigabyte base layer. It'll be pulled down the first time. Now for our container orchestration service, one of them is called ECS, which we'll talk about later. That layer we pre-cache that on the server, so if you're pulling down container images that were based on Windows Server 2019, it's not going to go fetch them from Docker Hub. They'll already be cached locally. But regardless, it would only get pulled down once anyway, because as you place more and more containers, it's just the read-write layer that has to be created as a copy. And that's why these things can get spun up so fast, additional ones, because the core read-only layer stays the same. It's just the read-write layer that each new container has to have instantiated. Okay.
Well, I'll just finish one thought on that previous slide, which is if you look at the size of disk used, I don't know if I'm going to be able to keep this up. If you look at the size of the disk used, it's saving disk, right? If I have 10 copies, it still only uses the same size as if I only ran 1 copy. If I ran 100 copies, and maybe I have 100 different apps, it's only that 50 meg or however big my app is that gets added for each one. So
And
it
even
really
though storage
reduces
is
your
cheap,
disk
it's not
footprint.
free, right? And so you save time and storage space.
And installation time, because even though this is cheap, that still has to come across the network on the install, and it installs once.
Man, your
The way
voice
to do it
fading.
is to do a Docker pull. Here, Microsoft has updated where their images are. It's no longer on Docker, it's on Microsoft's mcr.microsoft.com. And there's 3 main images. There's Nano Server, there's Server Core, and then full-blown Windows. So Nano Server is their smallest one, and we're going to go into that in the next slide. No, we're not going to go into that in the next slide. That's in 4 slides. First, we're going to talk that it's the smallest available. It's only 64-bit, but so is all of Windows Server now. There's no graphical applications. It downloads, it's about 100 meg in size right now, and expands to about 250.
Yeah, so it's very similar to a Linux container in size. I mean, if you get the .NET Core Linux container, that's like 80 megabytes around there, 80 to 100. So Nano Server is actually getting close to that in size, although it's .NET Core only.
Yeah, and it's got, there's no graphical environment really to log into. It's got a simple thing to fix the networking. Other than that, everything's done remotely to manage it. And then let's go on to the next one. And then there's Server Core. And Server Core is basically Windows full-blown server without the GUI on top. And so the GUI's been ripped out, and hopefully you've seen and heard of Server Core before. But it's a bit bigger. 2 gig or so, I'm guessing.
3.5?
3.5
we have the
gig?
sizes in a minute, but I think it's 3.5 compressed and about 5 uncompressed on the disk. So it's still not horrific.
The benefit is it can run the .NET framework, whereas Nano Server cannot. Nano Server is .NET Core only. But this is full server. And Windows PowerShell, not just PowerShell Core. And now this is a new thing that they've released with Server 2019, which is a full version of Windows Server. It has the desktop APIs and such in there as well. And so this is something that you can use for automating and testing of GUI APIs. You can have access to the GPU. There's a full API, including DirectX for video.
So if you were, for instance, running Selenium tests or using Chrome driver to automate your website test, and you wanted to run that in a container, you can actually do that now with the full Windows. Now the container is not small, and we'll see the sizes here in a second. The full one, oh yeah, the Windows Server Core is only 1.5, and it's 5 uncompressed. The full Windows is about 3.5 gigs and 11 gigs once it decompresses, which is not small, but it's still smaller than a complete Windows Server installation that you were doing.
Well, and these are the latest right now, version 1903, right? They have a new version come out every 6 months, and these, 6 months ago were a bit bigger, and 6 months before that they were a lot bigger. And so we'll see if they were able to keep that up. I think they're probably getting to the limit right now.
My guess is it goes down and then they start adding stuff and it will go back up, but we'll see. Okay.
Servicing channels. So it's just like Windows 10. If you're not familiar with what is going on, there is a long-term servicing channel. And so like Server 2019 is a long-term servicing channel. And then Server 2019 version 1903 is a new version of it. And if you think about the version 1903, where that comes from, is that's 2019, January, February, March.
Or
right?
1903, it could be, it's the year the Wright brothers flew the
Really?
airplane,
Yeah.
I think, right?
That
Maybe.
has nothing to do with it.
Okay.
Because if you look at the previous one, it's 1809, which came out September of 2018.
Another good year.
And if you go before that, it was 1803. And so the reason it's the year first is because they always get bigger, so we can start to do things in PowerShell to say, I want the latest version, that kind of stuff.
Version compatibility. So if you see the green here, this is the host on the top, and then the container version down the left. If the container version, OS version, matches the host, then it can run in what's called process isolation. That's what we talked about before, where they're sharing the same underlying kernel without having to use Hyper-V. So if you're deploying onto, using ECS to deploy onto normal EC2 instances, which are already virtual machines, that's what's supported, is in green. If you're running on bare metal or on your own laptop, which is probably bare metal, then you can do the ones in yellow, which is Hyper-V, and that's where it's It's a container running in a stripped down virtual machine, so it's a little bit bigger than just a container, but it's still not horrible. And if you're in red, you just can't do it at all. So if you're looking to deploy onto ECS and not have to go bare metal servers, the green is what you're going to be looking to do. And really, you should be looking at the latest version, so Server 2019, and you want your containers to be built on Server 2019 as well. And that's the demo we'll do in here in a minute.
The other thing is you get your best performance there, right? Because nested virtualization, usually you're going inside a virtual machine already, and then to do a virtual machine inside a virtual machine really has performance degradation consequences. So that's the fastest, is that green channel.
So for the sample app, we're using the original source code from Scott Hanselman's Nerd Dinner, except he added a bunch of client-side stuff, and now he's got maps and all kinds of stuff. We just took the original ASP.NET MVC 1.0 code. We retargeted the code for .NET Framework 4.7.2, which is now considered legacy, because 4.8 has brought more compatibility with .NET Standard. And SQL Server Express local DB. So what we're going to do, Nerd Dinner originally, it uses SQL Server in the back end. We're going to put the ASP.NET web app in one container, SQL Server Express in another container, and then we're going to show them running locally with Docker Compose, and then we're going to show them running, or show how you push it up to AWS ECS, which is the Elastic Container Service, or sometimes people call it EC2 Container Service. I don't know why. So we're going to show how all that works. So I think this is the demo. All right. So I'm going to pray to the demo gods really quick that nothing breaks. OK, so let me pull up Visual Studio first. So in Visual Studio, hopefully people can see, this is the Nerd Dinner. And then I have two Docker files separately that are in separate folders. Normally, the Docker files just at the root of your project. In this case, I just have them in two other folders. That doesn't make any difference. If we look at the code, this is just a very standard, whoops, sorry, I meant to do controllers. So this is just standard ASP.NET code. Anybody who's done .NET would know immediately what this stuff is. The two important parts of this are the two Docker files. If you look at a Docker file, let me do this so you can see it a little better. The Docker file is using what's called a multi-stage build. I feel like my cursor is going away when I'm, oh, that's not good. OK, well, I have no cursor in the code.
We can see it up here.
Oh, you can see the cursor up there?
Yeah.
Oh, yeah. OK, well, I'll just look up there, because that's convenient. The Docker file is doing a couple things. It's first, it says create a working folder in the Docker container called CSRC source code, and I'm going to copy my CS project into there and run NuGet restore, because the container, whoops, I'm missing, I think I'm not scrolled up. Sorry. The very first thing is from. It's saying from this particular container, which is a container Microsoft publishes. It has the .NET Framework 4.7.2 SDK. That means it's got NuGet, it's got MS Build, it's got the build targets for web apps that normally you get by installing Visual Studio. It has all that stuff to do builds already in that container. So that's the base layer. Then we're going to create a layer on top and say, I want to copy in my solution file and my CS proj, and then I'm going to run NuGet restore. So that's going to pull down all my NuGet packages and put those in that layer. Next, I'm going to copy, and if you look, it says like copy current folder to C:/source. In the context of Docker, when you do a copy, it's actually, this means copy recursively the entire current folder. So that's going to grab all of my source code, all of my .cs, C# files, my views, everything. It's going to copy all that stuff into the same working folder, and then it's going to run MS Build, which compiles it in release mode, sets the output path, and then finally, once I've got all that done, I'm going to create a new Docker container using a different base image. This one is pulling from ASP.NET 4.7.2. That means it has IIS, it has ASP.NET already configured, and I'm pulling it for the latest one that Brian talked about, the long-term support channel 2019. That's the container I actually want to deploy. The top one up there is a throwaway. I'm just using it because I want MS build and NuGet and all that stuff, but I don't want MS build in the container I deploy to my production environment because it's just using up space, it's extra code, the container's bigger, it's got a bigger attack surface. So I don't want that stuff in the container that actually gets deployed. So all the way down to pound app image, the app image comment, that's to do the build in one container. The output gets copied, and I'm going to say from this lean down production container, I'm going to then set some environment variables. I'm going to configure my website with some PowerShell commands in there, basically name it web app and tell IIS to run. So once you get down, whoops, yeah, I really can't see my mouse. And then finally, it's going to publish. It's going to copy everything that I had built up in this build layer here. It's going to copy all that into that production container, and then that's sort of the last layer. So there ends up being like 6 or 8 layers because every time I copy something over, that's a new layer in the Docker container image. So once you have your Docker file done, you're going to build it. So I'm going to do Docker. You can still do Docker build, but that's sort of going to be deprecated, I think. So you're supposed to do Docker image build. I can say what file I want to use. So my Docker file is in the web folder. And then so it's actually telling Docker to run all these steps. It's just, you can see it's actually running some of these commands. It's copying a bunch of stuff. And ta-da, that was the actual compilation going on in the intermediate Docker image. And then finally, it's doing the copy, and then yeah. So that was it. So it didn't take too long to do that. I don't have the world's fastest laptop either. So once you've built the Docker file, the next steps are you're going to tag it. Tagging it just associates it with the repository where it's going to go. I mean, you can use tags for a lot of stuff. In this case, I'm going to tag it with the Docker repository where I'm going to push it to, and then I'm going to push it. So tagging, you can tag your image, tag any container image with /prod. You can add tags to them. Tagging is also, it reminds me a bit like in Git, if I assign a remote repo for Git, when I do a Git push, it knows where to push it. Once I've tagged it and I do a Docker push, it's going to know where to push it. Rather than copying and pasting, I'm going to go find the last place I tagged it and just scroll up a minute. Maybe? Wow, I did a lot of stuff since I last did this.
We were playing around in it before.
Docker tag nerdinner/web latest. That long, don't copy my account name. Oh, you know what? Let me make the font bigger here. How about?
But if you want to copy that account name, a photograph would probably make it easiest.
No. Okay, so that's my AWS account number, account ID, but that's the URI of the container registry where I'm going to push it. It's my account number.dkr.ecr, because that's the Elastic Container Registry or EC2 Container Registry, blah, 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 blah. And then I'm going to tag it with latest, because later when I tell ECS that I want to run copies of that container, I'm going to say run the latest. Although you could specify an earlier version if you wanted. So now it's tagged, I'm just going to push it up, which eventually, I could just let me just find where I did this. Or maybe it would be quicker if I just did the copy paste. There we go. So Docker push, it's the exact same long URI basically. So when I push that, in this case, I pushed this earlier. So I'm just going to show you really quick though, because it's all built in layers, and the biggest layer is the OS layer, and my app is really small. Even if I go and change the app, and I come into here and go to, I don't know, let's go into the home controller and say, I can't see my cursor there, and say, hello, public sector summit attendees. All right. save. And because I'm a good developer, I always right-click and build before I push things up to production, usually. So I think that built, okay. So I will flip back over. We will do the Docker build again. So it's going to do the same thing exactly as before. It's going to create a container from the base image. It's going to do the MS build inside that container, take the output and put it in the production container that doesn't have MS build and NuGet and all those things in it. And then I'm just going to push it again. And it'll only push the difference. It's going to push just the layer that changed, and which will be very, very quick, even on the free Wi-Fi here in the convention.
So can you tell them, define a little bit what container registries are? I mean, it's a file share, right? And they're simple.
I can't quite hear you.
Yeah, I was asking if you could say it because I can't.
Your Docker push. Okay, so that was so quick, we didn't even see it happen. Okay, so that got pushed up, and to prove it pushed up, and to Brian's point, a container registry is just a place. Now that image could be, in this case, it's, I don't know, 2 gigabytes or something. Could be a 5 gigabyte or something if it was based on the full Windows Server OS. That image has to live somewhere where the place you're going to run your containers needs to be able to get to it. So a couple common places are Docker Hub, which is where even Microsoft, until recently, kept their Docker container images. AWS, I believe we actually published some stuff on Docker Hub, maybe, I'm not sure. We have in your AWS account, if you have an AWS account, you already have a private container registry in your AWS account called ECR. So that's where I push, when I did the Docker push, I told it, push this container image that's sitting on my laptop up to ECR. And so we'll go look at it right now. This is ECR, make that a little bigger. If I click on repositories, you can see I've got 2 repositories. Nerd Dinner, that's the database, which is SQL Server Express container image. And here's the one that we just built and pushed. So if I go into here and look at latest, woo, you can see it says it was 6/11/2019 at 5:56 a.m., which I think that's just a time zone issue. Also, I'm doing all this in Oregon because I live in Portland, Oregon. I think I mentioned that in the beginning, or maybe not. I live in Oregon, so I'm in the US West 2 Oregon region, so I'm not sure how that affects the time zone changes here. But this will be the one that I just pushed up. It's actually really small. It's 128 megabytes, which is, that's just the latest, the layer, right? Let me see if I can scroll over here. Yeah, so the base layer of this is over a gigabyte, but the layer I just pushed was only 128. Okay, so once you've pushed this image up there, how do you get, in ECS, how do I get that to then deploy onto servers? Because somewhere there's still servers under the hood, the hosts. Well, we're going to define a task definition, which simply says I have either 1 container or 2 containers, 1 or more containers. Here's how much memory and CPU I want to allocate to each container, and then that's a task. So let's go look at the task definition really quick. So if I go to the task definition, I have some other ones in here because I've been doing other stuff. I swear I thought I deleted some of these, but maybe not.
Aren't you jumping demos? Or we're going to go through and define this first in slides and then go into this?
Oh yeah, okay, we can do that. Yeah, I think I'm jumping ahead, so pardon me. So I've got Brian here to keep me honest. I can't see my cursor.
I have this amazing voice.
Whoa, that was interesting. Okay. Everybody can see my toast. Your notifications will remain quiet here while you're presenting. Thank you for notifying me of that. All right. So, yeah, I did jump ahead a little bit. So these are the steps I was trying to talk through, where I actually right-clicked and did the build in Visual Studio. The Docker file was already there, but we walked through it. Oh, I forgot to pull it up locally on my machine. Do we have time? 10 minutes?
Yeah.
Yeah, okay. I could have pulled that up locally on my own machine and showed you, which I totally forgot. We skipped ahead to push the container up to ECR, which is already there. I am going to just show you really quickly that you can actually run these things locally using a tool called Docker Compose. So I can say Docker Compose up, and then -D means detached, and then I think a period at the end, I hope. Whoops. Maybe no period. And done. So it already booted up and launched both of those containers locally. Now with older versions of Windows, I'm gonna lose my voice too. With older versions of Windows, if you wanted to then look at it locally, you had to go inspect the container and get the IP address because it's got its own IP and then use that. But in Windows Server 2019 and Windows 10 1809, they set up port forwarding. So my app is listening on port 8020. So now that's automatically port forwarded from localhost. So all I have to do to look at this is go to localhost, localhost:8020, and please come up. Might take a second. All right, because the very first time you hit it, IIS has to like spawn a process and, okay, so there it came up. So I have some very real events in here, like the Chief Nerd Dinner with Andy Jassy. Does anyone not know who Andy Jassy is? He's the CEO of AWS. So, like, don't show up in Seattle for this because I made these up, obviously. So this is actually hitting the SQL server, which when I said Docker Compose, it created in the Docker Compose file, which I'm using locally, which apparently I don't have up. Nerd Dinner, Docker Compose, there we go. Okay, so Docker Compose is just used, I'm using it to run these locally. It just sets up some networking and tells me that this container with the web app depends on the database container. But the real app it's now up and running, and it's hitting the ASP.NET app as one container and the SQL servers in the other container.
And
Okay.
the Linux guys used to pick on us in Windows containers all the time because we couldn't hit localhost. Well, now we can. Huh? Oohs and ahs for that.
Progress.
That is progress.
All right. So back to the presentation. I think we've got like 7.5 minutes, so we're going to try to speed up a little bit. So I talked about this already, multi-stage builds. I have a throwaway middle container that I use to actually do MS build and NuGet, but I don't want MS build and NuGet and my source code in the image I deploy.
Why didn't they change the slides?
Whoa, what just happened?
Our timer says we have 7 minutes left. Are we off?
Okay. To the audio video people, we just lost our presentation and something else came up. So,
What you should be seeing here is...
what you should be, oh, there we go. Okay, thank you.
Thank you.
Microsoft SQL Server in a container. This is useful, I think, for me, primarily for developer environments. Like if I have an app that I'm going to run a bunch of smoke tests and Selenium apps on it, and it has to have SQL Server with a bunch of test data in there for my tests, I can deploy, just as I just ran them locally, I can deploy a container with my web app and a container with SQL Server, deploy them together, and then they can launch in 5 seconds. I can run all my tests in the container, get all the results, and then throw the whole thing away. So that's a way to have reproducible tests by having SQL Server in a container. I think, Brian, you're losing your voice. Did you want to talk about persistent?
I was just going to try and say that you would probably use a regular SQL server for this instead of a container in production. But there are areas where it may make sense to actually use a container instead of a production SQL server. But there are 3 ways to do it as far as saving the data, and because non-persistent otherwise. And so that using pipes to pipe it down to the file system is a standard way. It's possible in Windows to use a file share as well, and my voice just is not going to hold out.
That's okay. So I don't think it's probably worth going and watching me do Docker build, Docker tag, Docker push again, just for the SQL Server one. I did do that already, and I pushed it up to ECS so that it's already there. Whoops. So ECS is one of our 2 container orchestration services. The other one is EKS, which is Managed Kubernetes. which I believe we have beta support for Windows in Kubernetes, or is it prod?
It's prod.
We went GA with it. So if you have expertise in Kubernetes, Kubernetes is a little more complicated. There's more stuff to install, set up, and configure. It's not trivial, but you can also run Windows containers in our managed Kubernetes service. ECS, it's a bit easier. We've had support for Windows in ECS longer, so it's a bit easier to do. ECS relies on an agent. It runs the native Windows service, includes Docker 18.09, which is a pretty recent version of Docker Enterprise. There's a lot of new features that came with 2019, basically. So the first step to this is in ECS, and I can show you this, I think, in a minute. You build the cluster. Whoops. In ECS, a cluster is defined as the servers that your containers are going to run on. You can set scaling rules to automatically scale up the number of servers as your load goes up. Maybe during the day you have 8, but at night you might be down to just 2, 1 in each availability zone for highly available apps, right? We already talked about the task. The task just says, these are the containers I want. You don't have to learn any JSON for this. We have a GUI that I'll show you in a minute to define the tasks. And then finally, you create a service, which is a long-running instance of a task, which is itself 1 or 2 or 3 containers, and say, this is how I want them to be placed, the rules I want you to follow, and this is how I want you to scale those up and down. That's your task.
And for a traditional app,
Service.
you might only have one because a lot of our traditional apps can't handle running multiple copies at the same time.
So if I switch back to the console really quick, just so you know, this is actually the copy of this app that's up there and running on ECS right now. I deployed it earlier this morning, and I actually have a load balancer in front of it because I have 2 EC2 instances, 1 in each of 2 availability zones, and I deployed my task, 1 copy on each. So I have a highly available Nerd Dinner app. So it's a very complicated app, as you can see. If I go into ECS, we just talked about the task definitions. I'll go into the Nerd Dinner task. Let me up the font a bit. Here's the latest version of my task. I've gone through different versions because I was playing with some memory and CPU sizing. Under the hood, it is a giant JSON file, but you don't have to know JSON. You can come into the builder, and the main thing is it's got, these are the 2 containers that are in it. It's got the Nerd Dinner web container and a Nerd Dinner database. I gave them each 4 gigs of RAM. So that's the task definition. And finally, the service. Here's my cluster, Windows Server 2019. I have 1 service defined, the Nerd Dinner service. It's got running right now 2 copies of it. Each copy is a task. So I've got a web server and a SQL server here, and a web server and a SQL server here, so it's highly available. There's a load balancer in front. Anytime you want to update this, you just click Update. You can come in and change things. I can pick a different version of this. If I wanted to roll back and I turned out that my newest push was bad, I could pick an older version and roll back to it. There's a lot of stuff that you can configure with that. I think we're about out of time, which is why I'm trying to rush through this. So I'm going to switch back really quick to wrap up.
Modernizing.
Oh yeah, let's skip ahead to modernizing. So ultimately, if you have unlimited resources and you have lots of developers with lots of free time, if you can port your app to .NET Core and break it apart, that's the cleanest approach. But the reality is, for a lot of enterprise apps that are running, they're ASP.NET, they're on Windows, they're working fine, and you don't have a really big need. I mean, your developers probably want to go in and rewrite it because we always want to rewrite stuff. But the reality is you might not have the resources to do that. So one option you can do to take advantage of things like immutability, scalability, reducing your licensing costs, not as much as running it on Linux, but still reducing them a lot, is move to Windows containers. Some of the other migration strategies, which I just talked about, you can deploy them as they are to EC2. That's the least amount of work. It's the least amount of benefit financially. You could containerize them in Windows containers, which is what we were doing today. And then finally, the hardest one or the most work is going to be porting it to .NET Core. breaking apart monoliths, creating lightweight Linux containers, or even running some of them in Lambda functions. We have a feature for ECS called Fargate, where you don't even have any EC2 instances that you see. You just push up your container and say, run 5 copies of that. And you don't even, there is no EC2 instance to worry about. There's no, that's Linux only though. So if you're doing .NET Core, then that opens that up as a possibility.
But not having those servers is a tremendous cost savings, right? You don't have to pay for instances running 24 hours a day.
Okay.
All right.
We're actually
Thank
out of
you.
time. Thank you all for coming today. We really appreciated it. I made that word up.